All right, so good morning. This question is from the topic of rotational motion. Uh, let's go through the question. Before I go through the question, please ensure that you subscribe to this channel. We are giving conceptual clarity and a lot of practice for you. Okay, this will reduce the stress and you will be able to score high in the examination because of the emerging clarity. Thank you very much. Let's start the question. All right. So this is an inclined plane. The angle of incline is given to be theta. This is a ring. Okay? This is a ring which is in pure rolling. It is given in the question that the ring is in pure rolling. Now, let's discuss what are we supposed to find? We are supposed to find the acceleration of this particular ring. Okay. How do we approach questions where it is mentioned it's a case of pure rolling? I will just quickly revise this concept of pure rolling so that you can solve any problem of pure rolling. Okay, let's see. In pure rolling, first of all, what you have is static friction. You don't have kinetic friction involved in this motion. Kinetic friction, if it is there, will result in sliding or slipping. It will not result in pure rolling. So first of all, note that these questions have only static friction and the coefficient of static friction is given. Okay. What is the role of this static friction? This static friction gives torque because if the body is in rolling motion, pure rolling, it is rotating also. Someone needs to provide rotation to a body in pure rolling. So this rotation comes from the torque provided by the friction. I'm static friction. I'm just repeating. It is not mu k mg sine theta here. Please don't use mu k mg sine theta in pure rolling along the inclined plane or along the surface. Okay. First. Second is there is this point of contact where the ring touches the inclined plane, right? When it touches the inclined plane, the relative velocity of that point on the ring is zero. That is why if there is relative motion, you will see frictional force, the kinetic friction. In this case, the relative velocity of point of contact between the ring and the wedge is zero. Okay, so this point is relative velocity is zero. This is mandatory condition for pure rolling. Now, what happens to energy? Since kinetic friction is not involved, there is no loss of energy. So if you are releasing it from certain height, the potential energy gets converted into half mv square plus half I omega square, right? And then V is equal to omega r has to be applied to solve this question, and acceleration is equal to alpha by r is allowed. These two, right, also need to be used in this. These are applicable to pure rolling. If it is given, it is sliding down, it is slipping down, please don't use these. Okay, don't use these at all. Okay, now the question here was what is the acceleration of this ring as it comes down, right? That is the question. Now let's make a free body diagram. When we make free body diagram of a ring, sphere, disc coming down, how do we do? First of all, let's address the translational motion. Translational motion. It is coming down because of what? Because of what? Mg sine theta. So it is coming down because of mg sine theta, right? So this is the weight of the ring, and one component is in this direction, which is mg sine theta. That is for translational motion, right? When a block is sliding down, generally we use this component, right? Now let's think through. There is a static friction which is also working. What is the static friction doing? It provides the torque to make it rotate. A rolling body is rotating. Who provides it? Static friction. So now the torque is coming from the static friction. Fs multiply by R, right? This distance is the torque, right? So which is equal to I into alpha. I hope this makes sense, right? FSR. So now I'm writing the rotational part, right? So alpha, so static friction multiply by R, which is the distance between the center. This is the R you need to take, right? Is equal to mr square multiply by A by R, right? We can use this. So this is the equation of the static, sorry, the rotational motion of the ring. We have not written the equation for the translational motion as yet, but we have used this, right? A is equal to, so there are two unknowns if you ask me. One is Fs is unknown. The second thing which is unknown to us is the acceleration. Is the acceleration. So it is going down with mg sine theta minus the static friction is equal to m multiplied by a. Right? As simple as that. This is static friction. Note static friction, I have not written mu k mg. I have just written mu static because mu k mg is that normal reaction, right? That kinetic friction force. Here we don't have that, right? So let's substitute the values. Now, if I substitute the value, we have to find the value of acceleration here, right? We want to find A. So we have to get rid of Fs. So the static friction is equal to mg sine theta minus ma. I will substitute the static friction here. So mg sine theta minus ma into r is equal to mr square into a by r. Okay, so r cancels, the r cancels, and what are we left with? Mg sine theta minus ma, right? Because we have got this expression mg sine theta minus ma into r is equal to mg sine theta minus ma is equal to this r also goes away. You left with ma. So mg sine theta is equal to 2ma, and the acceleration comes out to be g sine theta by 2. This is the acceleration of the ring. It was given it is a ring, right? So I took the moment of inertia of the ring. Now let's calculate the frictional force. I will substitute the value of A here. So let's use this place, right, to write. So frictional force is equal to mg sine theta minus m into g sine theta by 2 is equal to mg sine theta by 2, right? You can see the frictional force is not that mu mg kind of force, right? So it is very different. It is mg sine theta by 2. So this is the way you need to solve. Whenever students see pure rolling, slipping, sliding, they tend to leave this topic. Please don't leave this topic. It's very simple. If you know these key points, it becomes very simple for you to solve it. After you understand these, you just need to write one equation of translational motion, which is going down, right? And then you have to write the rotational part also, right? So which is the torque part of it, right? So the torque. Solve these two and you will get the answer as these, right? So the frictional force is static, remember that. Please don't use mu k mg and try to solve it. So I hope you like this explanation. You can see, answers in a lot of places, but Where do you find explanation? Only on this channel. So don't forget to subscribe to this channel and wait for my next video. Thank you very much.